Hello, I'm back at it again. I decided to take that nasty cheap RC transmitter that I got with my old Hubsan X4 for $35, throw that nasty piece of crap in the trash and buy a proper RC controller unit. Haha, just kidding. That's not how we do things here, is it? So we're back with this. It's tidied up a lot though. I kept it all together pretty much, and I've put the sticks back on here, and what we have in there is an Arduino Pro Mini, just kind of crammed in there. Actually sits in there pretty nicely, and there's the RF thingy on there. I actually have a high power one on here, which I've been doing some range tests with. So this is quite a convenient frame to mount everything on, because it gives me, obviously the sticks are here, battery thing is already there in the back. There's a power switch, which is a great improvement, because it means I don't need to hook up the Android tablet anymore. There's an LED to tell me that it's on, and there's actually a speaker buzzer kind of thing there that I'm not using at the moment, but that could be used. Plus I have a bunch of buttons, one up here. So I never would have suspected, but it turns out that a radio transmitter base is very convenient for building a radio transmitter on. Who would have thought it, eh? And so over here is this is the same thing I had before, just to check the signal. But these sticks are now a lot more responsive and smoother than the PlayStation ones were, because the dead zone in the middle is much smaller. So you can see it a little bit. I'm moving the stick as smoothly as I can, but as it gets towards the center line, it sort of sticks to the center a little bit. There's also a slight delay because of the screen being slow to refresh as well. But with the PlayStation controller, this dead zone in the middle was humongous. It was from about 30%, if you were within 30% of the horizontal distance to the center, it would snap to the center, and if you were within 30% of the outside of the range, it would snap to the outside. So it was almost a digital on or off sort of a direction control. But this is much smoother. I mean, I can keep the dot in, say, in the upper right quadrant of the right hand side there if I want to, lower left and so on. So it's we have pitch and roll and yaw. And another thing that will be quite useful for when I actually get this running on the helicopter is that this is already the spring has already been removed from this axis. So if I was using the PlayStation controller, I would have to somehow remove that spring myself. So as for the range tests, I took this down to the only place that I have available to do testing, which is a river by my house. And the river curves around, unfortunately, so I couldn't really get much of a long distance test, but using this antenna here I managed to get up to about 400 meters with no noticeable slowdown. And by slowdown I mean I'm measuring the rate that I'm receiving packets at on here, and I'm comparing it to the rate that I get when I'm standing right next to the transmitter. So to get this to work, I'm using I've disabled the auto AC in the RF24 library, which is on by default, so you have to turn that off if you want to just send packets as fast as you can without caring about whether the receiver is actually getting them. And to improve the distance, you need to slow the data rate down too, so I'm using 250 kilobits per second. This antenna here is a three whatever, you know what I mean. It's got three thingies on there. It's a cloverleaf one, so it's quite good for broadcasting signal in a roughly spherical pattern, and it has a nice little connector here which goes onto the thingy there. I just picked up this one today, which is a bit more of a regular one. I haven't tried this one yet, but I'll try that one tomorrow and see if it's actually any better. It's probably, I'm guessing it will be roughly the same, but I don't know. So yeah, up to 400 meters, it should be a pretty solid connection, which is much further than I'll ever be driving or flying anything. And speaking of driving, I got an RC car to test all the stuff out before I start flying a helicopter. As I said before, it's a lot safer to keep something on the ground. I'll just show you the helicopter I have. Right, quickly. It's pretty neat, huh? It's a little 250 quad. Most of these parts came from Banggood, which has been pretty good. They're a little bit slow on sending stuff, and the packaging is a little bit rough, but it's very cheap, and yeah, it gets here eventually. Okay, this is the RC car chassis I got. It's a Tamiya CC01 chassis, and it's fairly cheap, fairly common. It's 1/10 scale, so it's not too small, and I should be able to see it from a distance, and it's not going to get stuck on rocks and grass and stuff where I'm going to drive it. And I chose this one rather than all those buggy kind of ones that they make a lot of, mainly because it has a big chunk of plastic here that I can use to mount things on, and also because these parts here, the back and the front mudguard areas, are actually perfectly level. So it's quite good for mounting. I'm thinking of just mounting a huge flat, like A4 sized piece of plastic on top, so I can put other interesting things on top of it there. Speaking of interesting things on top, we have here another set of basically the same things that we have in the transmitter. So there's another Arduino Pro Mini, another RF24 module, just the normal one here, not the high power one. We have some batteries. Theoretically you can run everything off the main battery, but in practice it doesn't work out too well. So I have another battery there to run there's 4 AA batteries in here, and that's running the steering servo and the Arduino itself. Yeah, the rest of it is pretty standard. It's quite a trip down memory lane putting this together. I had a few of these when I was I think in high school, but they tell me that the battery technology is much improved now, so I'm looking forward to driving this. I haven't driven it yet, I've only just got it put together now. But anyway, so we have steering running from this channel, and it's quite quick to respond. I don't think there'll be any issues with that. And it's interesting, I noticed that I didn't do any kind of multi-receiver sort of setup for these radios, but can we see this? Yes. You can see that the other one is still receiving everything. So as far as I can tell, the transmitter RF module is just blasting these signals out to anyone, and there's no concept of like a connection. So whoever's listening can get that message, as far as I know. I did read somewhere in the datasheet that there's only 6 receivers, but I think that's for when you're doing acknowledging of packets. And I'm not too interested to find out whether I can transmit to more than 6 of these, but it's just interesting that it happens. So on this channel I have throttle, but it's not. So that's working like this. It's backwards at the moment, but it's pretty easy to change. You just change the Arduino sketch. You'll notice I'm being very careful with this one, because if you remember from just a few minutes ago, this stick here is made for RC helicopter, so if you don't put it right back in the middle yourself manually, the wheel's just gonna spin like crazy. So obviously that's why it's up on blocks here, so it doesn't go flying off the desk. As amusing as that might be for you, I'm not really interested in seeing that happen. So yeah, that's where we are at this point. Whoa. Anyway, maybe I'll make a video of me driving this, but maybe I won't. You can look at plenty of videos of people driving RC cars on YouTube. Just pretend that this one works. So, thank you for watching.